and welcome to the volume of 3D shapes with Cuboid Education. So we're going to go through looking at different types of 3D shapes and finding the volume, and we're mainly going to be concentrating on prisms first, and then we'll look at some some composite shapes, and even the likes of a pyramid and a cone for the higher paper. Okay, so first of all then, the simplest prism that we could look at first of all is a cuboid. Now, cuboids aren't necessarily seen as prisms, but technically they are. So a cuboid is basically just a 3D rectangle, okay? And you need to know the names of these shapes, okay? Because they might say that, and you don't want to be confused. Now, there's other types of prisms as well. So even though a cuboid is technically a prism, we also have something that might look like this. I'm not brilliant at drawing these shapes, by the way. And you might know that this is called a triangular prism. We could even have something like this, and that could be a hexagonal prism. Again, not that I'm very good at drawing, but we're kind of doing okay. Okay, hexagonal prism, because it's a hexagon, obviously. All right. Now, basically, all you need to know that is if it's a tunnel, so you can technically walk through it. If I cut this up, I'm always going to have the same shape. So it's like a tunnel. If I was a tiny person, I could walk through it. And a tunnel is basically what a prism is. Now, a tunnel could be standing up though, so we could even have a cylinder, which is a prism, okay? And it's standing up, but you could still walk through it that way if it was lying down. So that is still classed as a prism, but we call that a cylinder. Okay, so really make sure you learn these names. So any of these shapes, I could cut them in, I could cut them like this, not very well obviously. And I would get the same shape no matter what, meaning that that is a prism. So 1, 2, 3, see, rubbish drawing, but anyway. Okay, so that is what a prism is. So let's start by looking at this cuboid again then. Here is our cuboid, and the best way, obviously, to find the volume of a cuboid, which I'm hoping you already know, is length times width times height. Now, what we're essentially doing here is we're finding the area of this face. Okay, so let's say that's 5, and that's 5, and that's 10. Okay, that's 10 centimetres, 5 centimetres along there, and 5 centimetres down there. So the first thing I would do is 5 times 5. Okay, so length and width. And then I would times that by the height, or this it might be standing up, so this would be the height, or basically the length. Okay, so you would times it by this length here, so that would be times by 10. Now when you do this bit, you're finding the area of this bit first, so that's 25. So you found the area, that's centimetres squared, so that's the area of the cross section, that's what we call it. And then we will do 25 times 10, giving us 250 centimetres cubed, because that would be the volume. Now, with a cuboid, you can just do 5 times 5 times 10, okay, to give you the answer. But the reason I explained it like this is because you will have to find the area of the cross-section for other prisms that aren't as easy as this one here. So the first thing we do is find the area of the cross-section, okay, so 5 times 5, and then we times by the height or the length there to find the volume. Okay, so let's have a look at another example then. So if we had another cuboid, but this time it's standing up, again, I'm going to apologise for my drawings if they're rubbish. Oh, not too bad. And this measured 6 centimetres there, and this measured 3. And your height was 10. Again, I like 10s, they're easy. So the first thing that you're going to do, like I said before, is find the area of the cross section. So you're going to do 6 times 3. Okay, and that's the area of the cross section. Now the next thing you're going to do is just times by this length here. So 18 times 10. And that's in centimetres cubed because that's the volume. Okay. Alright, so now we're going to move on to something a little bit harder. And we are going to look at the volume of a triangular prism. So a triangular prism now. So if you can imagine like a Toblerone, that's what a triangular prism is. I'm going to attempt to draw one. And if you're taking notes, I would suggest you do the same thing. Alright, so we have here, this measures 3 meters here. Your height of your triangle is 4 meters. And the length of your prism is 12 meters. Now then, remember what we have to do when calculating the volume of a prism is we need to do the area of the cross section first. And then we multiply that by the height or the volume or the length, sorry. Of prism. Okay, so that's something that you really need to remember when working out any volume of any shape. So just like we did with the cuboid, we found the area of this section first by timesing that length, and then we multiplied it by the length or the height of the prism, which is exactly what this is. Okay, so just make sure that you remember that. Okay, so now what we're going to do is we're going to work out the volume of this prism, but this time it's a triangle. And in order to work out the cross section, which would be this bit of the triangle, we need to know how to work out the area of a triangle. So the area of a triangle, we need to do base times height divided by 2. Well, the base is 3 and the height is 4. Okay, and then that's divided by 2. So that leaves us with 12 over 2. 12 over 2 is 6, so I know that that's 6 centimetres squared. Area of cross section. Okay, and then all I need to do to find the volume is this last bit here. Okay, so we take our 6 centimetres and we're going to times it by 12. Okay, giving us an answer of 72 meters cubed for the volume. Alright, so I hope that made sense. We're now going to move on to look at a cylinder. Okay, so a common cylinder that could come up in your exam is one that looks a bit like this, minus the bad drawing. We've got 3 centimetres there, and that length there is 20 centimetres. Now, as I've said before, you need to find the volume, you need to find the area of the cross section, and then we times that by the height or the length of the prism. Now, I know I keep repeating myself there, but it's something that I really do want you to remember for your exams. So, what we need to do then first is find the area of this circle then. Now, to find the area of a circle, we need to use the formula pi r squared. Pi r squared means that we're going to take this number pi and we're going to times it by the radius, and then we're going to times it by the radius again. The radius in this case is 3, so that's going to be pi times 3 times 3. For now, I'm going to leave pi as it is until right at the end. There's no need to do some extra working out if I don't have to. Well, 3 times 3 is 9, so we actually end up with 9 pi. That just means 9 times pi, which is what is actually happening here. I'm going to leave that as it is, and that's in centimetres squared because that's the area. Okay. Then, to work out the volume, I need to take my area of my cross section, which is 9 pi, and I need to times it by the height or the length, which is 20. Now, I can do 9 times 20, so 9 times 2 is 18, so 9 times 20 must be 180, and because I've got this pi, I need to put the pi on the end. So it's 180 pi. Now, on your calculator, you will just type in 180 times. You will then press the shift button. Okay, and then you'll press the button here, which is, I think it's times 10 to the power of x. Okay? That, pressing those two buttons together, like one after the other, will give you the pi number. Pi is 3.14 ... That will go on forever. So it's better for you to just put in 180 times and then press those two buttons. Okay, and it will give you that number there. Once you've done that, you'll have a final answer of 565.49 centimetres cubed, and I have rounded that to 2 decimal places. Okay, right, let's have a look at another example then. So the second example that we have here is one where the cylinder is lying down. This time we are doing it in meters, and this length is 120 meters, and this length is 30 meters. So let's put that in there. Sorry, trying to get my drawing right. Okay, so then again we need to find the area of this section here. So the area of the circle equals pi r squared, which equals pi times r times r. The reason that I write it like this out again is to remind myself of what I've got to put in. So then I know that I need to put in where r is 30, because our radius is 30 for this one. Okay, so it's exactly the same method that we've just used. Now, again, I'm not going to use pi until right at the end. So technically I've got pi times, and then I've got 30 times 30. Well, 3 times 3 is 9, and then I've got 2 zeros. So 0, 0. Okay. So it's actually going to look like this, 900 pi meters squared for the area of the cross section. Okay, now then the next bit we need to do then is we need to take our 900 pi and we need to times it by 120. Okay. Now if you've got a calculator, that's fine, you can do that on your calculator. If not, you could do 12 times 9, or 9 times 12, sorry. So let's write it the other way around so that we're keeping it in fashion. 9 times 12, okay, actually equals 108. But we've got 1, 2, 3 zeros, so 1, 2, 3. So it's actually 108,000 pi. And you actually end up with a really huge number of 339,292 .0 actually, so we'll leave it there, okay, or 0.01 to 2 decimal places. And don't forget that that must be, I'm sorry I've not written that out very well, in meters cubed, because it's volume. Okay, so now then we're going to have a look at a hexagonal prism. The hexagonal prism, I'm going to try and draw this as best as I can. So it's basically a 6-sided regular hexagon. They won't try and trick you, I hope, with this kind of thing. Okay, there we go, we kind of got it. Okay, so with a hexagonal prism, you actually need to split it up. So it's hexagonal, it's 6-sided, okay, and this cross section here, this bit, is the hexagon. Now with this bit, what we're going to do is split it into 2. So we end up with one trapezium here, and we end up with another trapezium there. Now let's put some measurements on there. So this bit here is 4 centimeters. Let's see if I can get 8 centimeters. So this is 8 centimeters from there to there. Sorry, I hope you can see that okay. And then, what else do we have? 10 centimeters just here. Okay, and also you have a height here of 3 centimeters. Now the reason that you need that is because you need to work out the area of the cross section, which is actually the area of a trapezium. Now the area of a trapezium is A plus B over 2 times by H. Now A and B are your measurements here and here. So that's basically this bit and this bit. That's A and B. And the same there, that's also 4. Okay, so just be careful with that. All right, so to do that then, we'll do that in yellow. We've got 4 plus 8 over 2, all times by the height, which is this one, which is 3. Okay, so 4 add 8 is 12 over 2 times by 3. Well, 12 over 2 is 6, and so 6 times 3 is 18. So that's 18 centimetres squared for the area of the cross-section. Now, the last thing that we need to do is we need to find the volume of the entire thing. Well, it's not the last thing we need to do, because technically we've only worked out one trapezium at the moment. Okay, all right. So we need to work out the volume. So to find the volume then, we're going to take our 18 centimetres squared and times it by 10. Okay, giving us 180 centimetres cubed. However, like I say, we've only actually found one of the trapeziums. So all we need to do is now times that by 2. Giving us 360 centimetres cubed for the volume. Okay. Okay, so what we're going to do now then is we are going to look at some composite shapes. So sometimes composite shapes can be a little bit tricky. Okay, so I suggest you take some nice detailed notes here. Now we have this kind of shape. I'm not very good at drawing these. So let's see, 1, 2, 3, 4, 5, 6, 8. Sorry, I have to count. Okay, I'm going to label this then. So this measurement here is 1 centimetre. Okay, and that's from there to there. Then this is also 1 centimetre. And then from there to there is 2 centimetres. I just want to make it clear. Okay, and from there to there is also 2 centimetres. And from there to there is 15 centimetres. Okay, makes it nice and easy when we're working out to label it properly. Now, in order to find the volume of a shape like this, what I'm going to do is I'm going to split it into 2. And all I'm going to think about at first is the cross section, which is this bit and this bit. Okay, we don't need to worry about this just yet. We'll come back to that later. Let's just look at this one shape as if this shape's all on its own. Okay, if that shape is all on its own and you wanted to draw it again, you can, and then label it just to help you. And what I'm going to do is I'm going to split that up into 2 shapes. So I need to first of all find the area of the cross section, which is obviously this shape here. So I'm going to split this into 2. I'm going to do A and B. So that means that that must measure 1, okay, and that must measure 1, because the whole thing is 2. Okay, and that's 1 there, so we know that's correct. So to find the area, we're going to do A first, and A is just 1 times 1, which is 1 centimetre squared. And then B is 1 times 2, which is 2 centimetres squared. So altogether, we have 3 centimetres squared for the area of the cross section. And all we have to do now, because we've found the entire area of all of this, okay, is we're going to do 3 centimetres times 15 to find the volume. Okay, and that's 45 centimetres cubed. All right, okay, let's have a look at another harder one. This time, okay, so again, I need to draw this out for you. So this is basically, if I can do it right, a kind of tin, I think. I think that's what it's meant to be anyway. And this should come to there, kind of. Okay, that'll do. It's like a tray. Okay, here is your 3 centimetres. This measures 15 centimetres. This measures 30. And this measures 20. Okay, so first of all, what we need to do is think about what shapes we have. So we can see here that this and this are going to be the same. which means it's a trapezium. That's the area of the cross-section, okay? So this is our cross-section. So we only need to find the area of 1. So the area of the cross-section, well, we can see that that's a trapezium, okay? Can we see that shape? That's a trapezium shape, okay? It could be drawn anyway, like that, all right? Okay, so area of the cross-section then. Your area of a trapezium is A plus B over 2 times by H. Okay, so just, again, make sure you remember these formulas. So we need to be careful with the measurements. We know that this is 15 along here, so that means that this top bit must be 20 because that's 20. So that must be 20 as well. So A is 20 and B is 15. All of that divided by 2. And then we times it by the H, which is height, which is this bit. It's the height of the trapezium, not the height of the container, because we're only finding the trapezium first. Okay, so times by 3. So that's 35 over 2 times by 3. 35 over 2 is 17.5. If we times that by 3, it gives us 52.5. And that's centimetres squared because that's the area of our cross-section. Now, for the next bit, all we need to do to find the volume is 52.5 times by the length of the shape, which is 30. Now, if you've got a calculator and this comes up in the calculator section, that's fine, you'll get your answer. If not, you might have to do something like 52.5 times 3, rather than times 30, okay, might be easier. If you do have to do that, there is another video on longer multiplication. So in order to do 52.5 times 30 without a calculator, we will do 52.5 times 3. So 5 times 3 is 15, carry the 1. Put your decimal in the same place. 2 times 3 is 6. Then we have to add this 1. That makes 7, and then 5 times 3 is 15, and we can just put the whole 15 on because there's nothing else to times by and nothing else to carry. So 52.5 times 3 is 157.5, but that means then that 52.5 times 30 must be 1,575 centimetres cubed. Because I have this 0, I have to move my decimal point 1 place. And as I've previously said, there is a video on that. But if it was in a calculator paper, you can just put that in your calculator to give you the final answer. Okay. Okay, so let's have a look at another type of exam question that you could get. So another triangular prism now, just to recap. Just kind of going through some exam questions as well as we go. So this triangular prism, again, try and draw these as accurately as you can. 1 metre high, 1.5 metres across, and then this one here is x metres. And what it wants you to do is find x, okay? And it also gives you the volume of 42 metres cubed. So in this question, it's given you the volume, okay, but you've got to work out this length. So in order to do that, I would think, right, well, I can find the area of the triangle. I can find the area of the cross-section, because your formula is the area of the cross-section multiplied by the length or the height of the shape. Remember? Okay, so if that's the case, then first of all we can actually work this bit out. So the area of the cross section, so the area of the triangle is base times height over 2. Well, that's 1 times 1.5 divided by 2, which is 1.5 divided by 2, which is 0.75 meters squared. So I know that my triangle is 0.75 meters squared. Okay, 0.75. Now, this most likely will be on a calculator paper, so don't panic. So now, looking at our formula, we know that the area of our cross section here, well, we can say the area is 0.75. I must times that by the height of my shape in order to find the volume. And I know that my shape is x. Okay, so I can say 0.75 times x equals, and it tells us the volume just here, 42. Okay, so in order to find out what this length is, we need to know that 0.75 times something equals 42. So instead of, we can work backwards, so we can just divide 42 by 0.75. So x equals 42 divided by 0.75. And if you put that in your calculator, 42 divided by 0.75, you end up with x equals 56 meters in length. So you've worked backwards to get that answer. Okay, so I hope that made sense. The last thing I just want to mention on this is that you could get a shape that looks a little bit odd. So maybe something like this. I don't know. Okay, and they'll make it look kind of 3D. So it's like a 3D shape. Okay, something like that maybe. I don't know. Okay, so it's a 3D shape anyway. And they might tell you that the area is 42 meters squared. And they might tell you that this here is 10 meters. So all you need to do really, rather than actually working that out, you don't need to find the area of this because it's told it you. Okay, so the area of the cross section is already given to you. And it wants to know the volume. Okay, so what is the volume? Well, you know that the volume is the area of the cross section multiplied by the length or the height. So you know that the area of the cross section here is 42 multiplied by the length, which is 10. So you know the volume is 420 meters cubed. So you won't actually have to work out the area. It will be given for you, and it will be a tougher shape like this. Okay, so you know then that you can just multiply those two together to give you the volume. All right. Okay, so there's a couple of questions that I want to go through that are on the higher paper. So that is mainly the volume of a pyramid. So volume of a square-based pyramid. Okay, and so let's draw one out and have a go. So let's see if I can draw this. I'm not very good at drawing these. It's really hard. Okay, so again, if you kind of copy the way I've drawn it, you might be able to actually, not too bad. Okay, and there's your kind of center of your pyramid. Okay, this bit here measures 8 meters, and this bit here measures 21 meters. Your height is 26 meters. Your height being from there to there, the base of the pyramid to the top. It is not this length here, it is this height, okay? Right, now in order to work out the volume of a pyramid, you need to use this formula. 1/3 the area of the base times the height. So in order to work that out, you need 1/3 the area of the base. Now the area of the base is a square. Is a rectangle rather. And a rectangle is nice and easy. We just do 21 times 8. So times 21 times 8 times, and then the height is 26. So here, that's the area. I'll work that out in a minute. That's the height, and then we've just put the 1/3 in. I want you to leave the 1/3 till last. Okay, we'll do that at the end. So now V equals 1/3, and if I multiply 21 times 8, it gives me 168 times by 26. Now, all I need to do is times these two together now. That will give me 3,368. Okay, and if I find, all I need to do now is find a third of this, because it's a third times that, meaning I find a third of it. So you can just divide it by 3. So your volume in total will be 1,122.67 meters cubed. Okay, so finding the volume of a square base pyramid isn't too hard. You just need to remember this formula, area of the base times h. Area of the base, that is. Okay, don't forget that. Alright, okay, so let's go through a sphere as well then. So if we look at how to find the volume of a sphere, so here is a sphere. And a sphere, it's meant to be round, obviously. There's the radius of a sphere. Okay, I'm just going to make it look a bit more like a sphere-ish. Okay, so if that's your radius of a sphere, the volume of a sphere, to work it out, is the formula 4/3 pi r cubed. Okay, r shouldn't be big. I don't know why I've just done that. It should be small. It should be a small r. Because big R and small r are different things, okay? But usually if it's an R and it's written there, then I would assume it's the radius, so don't panic. Okay, so if we have a sphere then instead with a radius of 5 meters, how would you work out the volume? So we are going to write down the volume equals 4/3 times by pi, which we will come back to, times the radius, times by the radius again, and times by the radius again. And that's because we've got this 3. It doesn't mean the radius, which is 5 by the way, times 3. It means the radius times the radius times the radius. So let's put our information in. We'll leave pi as it is until right at the end. So r is 5 in our question. Okay, so 5 goes in there. So that actually equals 4/3 times pi times 5 times 5 is 25. 25 times 5 is 125. Okay, so now what we need to do is just put that all on our calculator. Now, if we did this pi times 25 bit first, we end up with, so pi times 25, 392.6990816968. Obviously, you don't need to write down the entire number at the end, but I would, for now, use that number in your calculator. So once that number's in your calculator, then you can do this last bit. Okay, so all you need to do is either on your calculator take this number and press divide by 3, and then press equals, and then press times by 4. Okay, so that's one way. So you could divide by 3 equals and then times by 4. Or on your calculator, you have a little button that looks like this on a scientific calculator. If you press that, it will let you put the numbers in. And then if you click your arrow to the side, you can then press times, and then you can put in 125 pi. And if you want to put in pi, I have gone through this already, the button is shift and then the times 10 to the power of x button. Okay, and if you put all that in, you could even put a times in there before you press the pi button if you want to, just to make sure, and you will still get the same answer, and your answer should be 523.6 meters cubed, which is the volume. If you haven't got a scientific calculator and you need to get one, I suggest you do, because when I talk about things like this, it will help you if you did it alongside me. It might help you understand what's going on. Like I said, there is going to be a video on scientific calculators, so please make sure you watch it. Okay, so now then, let's have a look finally at the volume of a cone. So a cone, again, if I can draw one, looks a bit like this. So this is going to be an upside down cone. Okay, and let's say it's got a radius of 3 meters, and it has got a height of 5 meters. This here is just the length of the side, which you don't need, okay? So it doesn't matter. If they give you something for this, don't use it, okay? Because all you need for the cone is the volume equals 1/3 pi r squared h, okay? So leave the third till last again, and this means 1/3 times pi times r again times h. Okay, remember the two r's is because of that too. We must times them by each other. Okay, so then we can put in our information. We can leave pi as it is. R is 3 and h is 5. Again, we end up with 1/3 times pi times, well, 3 times 5 is 15, 15 times 3 is 45, so we can put that in. And then we can write it like this, 1/3 times 45 pi, because pi times 45 just means 45 pi anyway. And then all we need to do now is you can work that bit out on your calculator if you want to. Okay, if you did that, you would end up with V equals 1/3 times 141.3716. If you get a longer number, I would leave that on your calculator. You will get a longer number, I think. Yeah, you will. So if that will continue to go as long as possible on your calculator. And if you've got that answer on your calculator by doing this bit, all you need to do then is just press divide by 3, because that will find you your third. So V then will equal 47.12 centimetres cubed. And that's the volume, remember, V, obviously. Just checking. Okay, so well done. You've done really well. That was a lot of volume, a lot of formulas. Please try and remember them. This one as well, please, you need to remember these formulas. They're not in the books anymore. I definitely don't think. They're definitely not all in the books. I'm not sure about the cone, but I would try and learn them anyway, just in case. Okay, so well done. Thank you so much for using Cuboid Education, and I hope to see you next time.